Cool. Ahan, as feasible, turn on the video as well, please.
Yeah, sir. Sorry, I just joined from another class.
Okay.
So
Cool.
which topic are we doing today?
Yeah, so we're going to be doing sequences, arithmetic sequence and geometric sequence. So today is 22nd April. So technically this is the first class, right? I mean, the last class was the demo class. So we're going to be doing arithmetic progression. There's a slight difference between the word progression and sequence. It's just a technicality, so don't worry too much about it, but know that there is a difference. I don't want to confuse right now. Geometric progression. Okay, so this is denoted as AP, and this is denoted as GP, right? You might have heard of, you guys have heard of this name, AP, GP, Avya? Avya, as usual, all smiles, that's good.
Yes.
You've heard of this name? Okay, AP, GP. There's also a third one called harmonic progression, which is not there in the syllabus. Obviously, they can make up a question without revealing the name or something, right? So it's good to touch on HP as well, slightly. Okay, so before that, let's understand what a sequence is. So I can have any sequence. For example, this is a sequence of perfect squares, correct? So, and then I can have a sequence of prime numbers and so on, right? So a sequence is just, as the name suggests, a sequence of numbers following a certain pattern, right? That pattern can be anything. And you can define a sequence in one of two possible ways. You can directly say what the nth term is. So for example, in this case, u suffix n. Typically, it's u for the nth term. So if u for a general term, u or a, one of the two is used, right? A suffix n or u suffix n is denoted, is used to denote the nth term. So in this case, I would simply say is n square. So for a specific n, it automatically gives me what that term is. For example, a3 is 3 square. So the third term is 9. That's what I'm reading from this new notation, right? And in this case, it's not possible to define. You can only say un is the nth prime number, right? It's not always possible to give a mathematical representation to it. You might have to list it out, write it out as a sentence. That's possible. Another possibility is, so suppose I have, let's say, I mean, you guys know this. What is this? What is this called? What is the name of the sequence?
Fibonacci sequence.
Fibonacci, right? So Fibonacci. So again, writing the nth term itself, there is a mathematical formula where you can write the nth term, but it's better off. It's easier to write it in terms of the previous term or terms. So in this case, we can clearly see that any term un is nothing but a simple sum of the previous two terms, un minus 1 plus un minus 2. Right? So you're not giving a general expression for un, but you are defining it in terms of the previous term or terms. But obviously, this cannot go forever. For example, if n equal to 100, it's fine. I can say u100 is u99 plus u98. But if n is a small number, so let's say u3 is also fine, u2 plus u1. But how do I define u2 itself? How do I get this 2? Or how do I get, I mean, the Fibonacci series, some people start with 1. So they say 1, 1, 2, and so on. You can start with any number and have this pattern really, right? This is my own made up Fibonacci, you can say, right? You can start with any two numbers really. My Fibonacci numbers can start with 6 and 17, for example. And I'll say these are my first numbers. And I can go 23 is the next term, 40 is the next term, 63 and so on, right? So the idea is you start with two terms and then every successive term is sum of the previous two terms. Okay, so this works as long as n is greater than 2. But somehow you have to define what u1 and u2 are. So there's no way, but you just have to literally state it. So u1 equal to 2, u2 equal to 3. And then for any n which is greater than 2, use this formula. So that's another way of defining a sequence. Okay, so So in a sequence, so two things are important. One is the nth term itself, as we just saw, un or an or whatever it is, right? The other is Sn. So Sn is the sum of the first n terms. Sum of the first n terms. Okay, so you guys might be aware of this sigma notation. So I want to introduce the sigma notation in case you're not aware. So sigma notation, you would have seen this symbol, which is like an inverted E, right? So this is stands for sigma. So in this case, it's just summation of all AIs, right? As I goes from 1 till n. So the way you read this is summation of the E symbol, which is reversed E symbol, is the sigma notation. What is the general term, which is AI? And then where does the I go from? I goes from 1 to n. It might not always be that you want the first n terms, right? So this is my Sn, right? Sn is the first n terms. So there I goes from 1 to n. So for example, suppose I want to just say A3 plus A4 plus A5 plus A6, and that's it. Let's say that the sequence has 100 terms, A1 to A100, but I'm not interested in the rest. I'm only interested in these 4. Then I can say the particular sum that I'm seeking, let's say S, whatever, I'll just say simple S, right? Nothing, right? This particular sum I'm seeking runs from I equal to 3 to I equal to 6, right? And in general, AI can have a formula. So for example, in the first example that we saw, it is square, right? So I can have sigma, I can either write AI, or I can actually write the formula that defines AI. So in this case, let's say it's I square. So so as a notation to write the sum of the first 10 perfect squares is I equal to 1 to 10. So you give the starting point at the bottom and the ending point at the top, and saying the I equal to the top is optional. So it's good to say, but it's obvious, right? We are only talking about I is the running variable. So if this is the starting value, the ending value obviously has to be this. So sometimes people just skip this.
So I have a quick question.
Yes, please.
So like, so I think I missed it, but what does AI mean? Does AI mean like sum of all the things, or is
No,
AI
AI
is like
or
the nth term? Is it just
nth term, ith term is AI.
Okay.
An is the nth term, A suffix n.
So then I got it.
Yeah. Yeah, when I say an, it's not the product an, it's a suffix n, but it's too much to say every time suffix. It's understood AI means the ith term, a suffix I. Okay, so this is sigma I square, I equal to 1 to 10. As I was just telling, you don't have to put the I equal to at the top, right? It's optional. Okay, so for example, there is a formula for sum of the perfects. Forget even this. So for example, can you tell me what this would be? So I goes from 1 to 10. So what does this mean? The term itself is in, okay, maybe I'll just put 3i so that it's a little less confusing. So I'll just say 3i. Right? So this means if I have to literally write out, it's like a for loop, right? When I equal to 1, 3i is 3. When I equal to 2, 3i is 6. When I equal to 3, 3i is 9, and so on, all the way till when I equal to 10, it's 30, right? So effectively, what is this? This is 3 times 1 plus 2, so on till 10. So the formula, right? 1 plus 2, so on till n is, what is it, Sumer? 1 plus 2 plus 3, so on till n. Avya, do you know?
Is it 55?
55.
It is 55, but did you literally add it up?
Yeah.
Okay, so suppose I say 1 plus 2, so on till 20, then you're gone, right?
Oh, no, okay. Then it's just, it'll be what? What is this? That'll be 210. It's like 1, I don't remember, with some formula.
Correct.
N by 2, something like that.
Yeah, it's n into n plus 1 by 2. So in this case, the 3 can come out here, right? So I'm adding 1 to 10. So the 3 is just a common factor. So summation is 10 into 11 divided by 2, right? Which is your 55 times 3. The 3 is just so that I didn't want to leave it plain I, just so that it's clear. So it's 165. Yeah, but it's good to recap these three, right? So sigma I, which is the sum of the first n natural numbers, is n into n plus 1 by 2. Note that the right hand side will not have any I at all. I is like a running variable. It's a temporary variable, right? It will only depend on n. It's a function of n. Remember that. Ahan, so far so good? Make sense?
Yeah, sir.
Okay. And summation of I square is also important, right? So suppose I want the first, sum of the first, we'll just try for a small number, some of the first 5 perfect squares, 1 square plus 2 squares, so 1 till 5 square, right? Of course, here you can manually do, but it's a bigger number. How do we do? There's an expression for it. So it's good to remember these expressions. N into n plus 1 into 2n plus 1 whole upon 6. Can you verify this?
This
Can you
for
veri-
squares, right?
Sum of the squares, correct. So here I have I squares, I square here. So can you just verify it quickly, guys? 1 square plus 2 squares, so 1 till 5 square. Literally do it manually first, and then check with the formula. Convince yourself it works. I'll give you a minute. Ahan, what's it working out to? 1 square plus 2 squares, 1 till 5 square. When you manually do it, what do you get?
So 55.
55. Okay. And using the formula, does it work out to 55, Ahan?
Yeah, so I'm just doing it. So-
Okay. All right. Yeah, anyone?
Yes, sir, it does.
It does works out, right? Okay, cool. And then the other one that to remember is obviously the cube, which is also an important one. Sigma I cubed. I cube. I goes from 1 to n, right? So this is very easy. It's n into n plus 1 by 2 that we had earlier for sum of the natural numbers, the whole square. So it's the first expression that we had, the whole square. So we can just quickly check. For example, n equal to 4 kili, we'll check. So 1 cube plus 2 cube plus 3 cube plus 4 cube. Manually, if you do, what do you get? You get 1 plus 8 plus 27 plus 64. That's 1 plus 8 is 9, 36, 100. We expect it to be 100. Okay, and what is this guy telling us? N is n equal to 4. So it's 4 into 5 by 2, the whole square. So indeed, 10 square is 100. So it matches. Yeah. So these three are very important. Sum of the natural numbers, some of the squares of the natural numbers, some of the cubes of natural numbers. Okay. And the sigma notation can be applied more generally. So for example, can you guys find out what is summation of 2i minus 7 as I goes from 1 till 20? Okay. Can you guys work it out? Do you understand what this means? Anyone not clear? As I rolls from 1, 2, 3, so on, so on, each term is given by 2i minus 7. You just have to find the sum. Can you guys work it out?
So I don't fully understand what 2i might mean.
Okay. Okay. All right. Sure. So this formula is saying I runs from 1 to 20. First, we start with I equal to 1. When I equal to 1, what is this? This is 2 minus 7. Literally 2 minus 7. When I equal to 2, it's 4 minus 7. And you're just adding. Because we are adding because it's summation. The sigma notation is telling calculate each term and then add them all. That's what it's telling.
So it's just a sum of all of these. Basically.
Exactly. Yes. All the way till 40 minus 7. So what will it work out to be?
So can I try?
Yeah, please go ahead. Yeah,
So I got 561.
561. Okay. I haven't worked it out myself. Sumair, same answer, different answer.
So 1 sec.
Sure. Ahan, you're working on it, right?
Yeah, so I'm not like fully getting it.
No problem. We'll discuss, but I'll just wait for someone else to call. Sumair, you're almost there.
Yeah, but I'm trying to figure out if I'm using the correct method.
Okay. So don't be biased by his answer. He may or may not be right. You just work it out yourself. Not clear, Sumair?
I'm just 1 sec. I'm just a little unsure. I
Okay.
don't think it's 5,
Okay.
6.
Okay. It is not 560 ab, yeah. So it should be less than that.
So, but I have a quick question. So, aren't you supposed to use the n into n plus 1 upon 2 formula?
Correct. But don't blindly use it. Use it as it's supposed to be used. Okay, we'll discuss. So, Abia, someone else had a question. Ahan, was that you?
Yeah, so I just didn't fully understand it.
We'll discuss. We'll discuss. Okay.
Yeah.
But I thought someone else interrupted with a question. No, Sumair, you're good. Okay, we'll discuss, right? So what is this? So literally I've written it out like this. I've expanded it out and written. So this all of us understand, correct? Okay. So now I can break it down. For example, this is just summation, right? I can write it as
So is it 280?
280 is right, correct. So I can write it as 2 plus 4 plus 6, so on till 40. This is the collection of all the positive terms. And then I can subtract off 7 plus 7 plus 7, so on till 7. Correct? That's what I'm doing essentially. So this guy is what? So it's 2 times 1 plus 2 plus 3, so on till 20. Ahan, you're with me? Please call out, guys. Right? If something is not clear, please call out immediately. Don't hold back. Okay. So it's 2 into, we know that summation of I is just n into n plus 1 divided by 2. Avi, are you with me? Okay.
Yes.
And then this guy is just a collection of sevens. How many sevens? 20 sevens. How do I know? Because it runs from I runs from 1 to 20. So it's just this. So it's 420 minus 140, which is indeed 280. But Avya, I would want to, Ahan, is this clear?
So I think I
Yeah.
used the formula in the wrong way.
Okay, I want to know what you did because it's important to learn the wrong method.
I thought as I used the formula, so I did 2 into 20 minus 7, which is 33, and then I used the formula. So I did 33 into 34.2. That's how I thought you were supposed to use it, but yeah.
Ha. So what you did was you just went for the last term, which happens to be 33, and then you said it's 1 plus 2 plus 3, so on till 33. Right? Your last term was right, but the previous terms were not 1, 2, 3, so on till 33. In fact,
Yes.
if that was the case, there'll be 33 terms, not 20 terms. Correct? Agreed?
Yes, I realized. Yeah.
Okay, cool. Ahan, you're completely okay on this? Convinced on this?
Yeah. So
Okay, let's try one more. Okay, so summation I equal to 1 to, I'll keep a small numbers just to illustrate. Okay, so 1 to 5, 2i cubed minus 3i square plus 7. Excuse me. You have all the formulas up here, right? So, okay, you have this, this, and this. literally write out the first few terms. And then that'll help. Just like how I have written. Don't calculate. Just write it as 2 minus 7, 4 minus 7, just like how I did. Write out the few terms, and then you'll see the pattern. I mean, the pattern is right there, but if it's not very clear, you can write out a few terms. Take your time to digest this.
So I'm not sure. So is it 292?
I haven't worked it out. Let's all do it together. But I'll wait for other answers. 292. Okay, that's Ahan. Okay. Anyone else? I'll erase this blocker so to make space. Abia Sumer, how much time more before we start discussing?
So just 2 minutes.
1 minute. Okay.
Just a minute.
Shall we?
So just quick 10 seconds. I think I'm almost.
Okay. Okay. I think we have spent sufficient time, right? Let's discuss, guys. It's okay if we don't get it. It's we're just learning this, right?
So I got 292, but I'm not sure.
Oh, isn't that's what this guy also got, right? Ahan. So it's
Yeah.
very likely both of you are right then. Or both of you are wrong. That's also possible. Let's see. Okay. Okay. So essentially, this is 3 different problems, right? So effectively, it's sigma 2i cube, and then minus sigma 3i square. I'm not putting the sigma I goes from 1 to 5 every time, but I'm just taking a shortcut, plus sigma 7. You can treat each of them separately. And then in each of them, the 2 can come out, the 3 can come out, right? So effectively, it's 2 times the sum of the cubes minus 5 times the sum of the, no, not 5, 3. 3 times the sum of the squares, right? 3 times the sum of the squares. And then it's just, if you want to write this also similarly, I can write it as 7 times sum of all the ones, right? The term here does not even have I. It's saying whatever I is, the value is 1. So it's 7 times 1 plus 1 plus 1. And I goes from 1 to 5 in all these cases. So now it's just formula substitution, right? So it's 2 times sigma I cubed is what? N into n plus 1 by 2, the whole square. So 5 into 6 by 2, the whole square, minus 3 times sigma I square was what? N into n plus 1 into 2n plus 1 by 6.
So I did this only and I got some, like I got 430. I don't know what I did there.
Okay. You could be right. Let's see. Okay. Plus 7 times 1 plus 1 plus 1. There are five of them. So 7 times 5. Okay. So let's check. So 6, how much is this? 15 square.
Never
6
mind.
into
I go what I did.
Found your mistake. Okay. So 15
The
square is
same, so
225.
yeah.
Yeah, so,
450.
so I think mine will be 320. So.
Yeah,
Yeah.
same.
So how much is this? 555, 165 plus 35, right? So it's 450 minus 130, 320. Is that right?
Yes.
Okay, cool. All of you in your second pass got the same answer, right? So
Yes.
found your silly mistakes. Just silly mistake, right? No conceptual mistake, right?
Yes.
Ahan, you want to just share what is the mistake you made?
So I just added 7 instead of 7 into 5. So.
So same.
Okay, cool. Nice. Okay. Okay, so this is this. Now, it looks like we are tied up with only being able to add from I equal to 1. If the starting point is not I equal to 1, suppose I want to, can you guys do this? Suppose I want to do summation of 3i. I goes from 57 to 63. How do you do this?
So do we do I from 1 to 57 and minus it from?
Exactly. Yeah, we'll do 1 from 1 to 63, and then we can subtract off 1 to 57 or 56 rather. Right? You can split it as two problems. I can do summation from 1 till 63. I can subtract off 1 to 56. That's one way to tackle, but it's clumsy, right? It's doable, it's clumsy, right? Agreed? Now, this is where the introduction to arithmetic progression comes. So what is arithmetic progression in general? Arithmetic progression is okay. You start with some number, let's say 4. So first, let me write out an example arithmetic progression, right? 4, 7, 10, 13, 16, and so on. Okay. So very clear. You're starting somewhere and you're adding 3, right? Any kindergarten will understand, right? Now, what are the two typical questions you want to ask? You want to ask yourself, what is the 97th term? Sometimes people use U, sometimes people use A, right? That's one question you want to answer. What is the 97th term, right? How do you quickly tell what the 97th term is? First, without any formula, let's figure out what's happening, right? So we are starting with 4, and then each hop is an additive hop, correct? Of plus 3, plus 3, plus 3, and so on, right? So for example, to reach the 5th term here, you had to go through 4 hops of 3 each, right? So we can just use plain logic and say, I'm starting with 4. I'm doing a certain number of additive hops of 3 each. And how many? 1 less than the number I'm trying to reach. So if I have to reach the 5th term, I had to take 4 hops, right? Therefore, it's 4 plus 4 times 3. 4 hops. I mean, this 4 and this 4 are different. It just so happened to be, in this case, the starting term is 4, right? And the number of hops is 4 in this case. And each hop size is 3. Does it make sense? Okay,
Yes.
that's okay, cool. So that's just my son. He was just telling in to listen a little bit. So he's in 8th grade, but he just wants to listen into some sessions, right? Okay, so that Sudarshan, keep yourself muted. Okay, so it's 4 plus 4 into 3. So what is this? 12 plus 4 is 16. Indeed, we get the same 16 as we got here, right? Right. How do we generalize this? So we can start with, so what is it that qualifies an arithmetic progression? To specify an arithmetic progression, you need 2 things. 1, what is the starting value? And 2, what is the hop size? So to define an arithmetic progression, I'll say, I'll start with some starting value A, right? Sometimes people give it A1 or U1, but A is good enough. And then you're specifying some common difference. That difference is D, let's say, D for difference, right? The next one will be A plus 3D. So here itself, you can see that the nth term, right? The nth term, UN or UN, will just be A plus the number of hops of D will be N minus 1. Do you agree? And that's it. The nth term in an arithmetic progression is simply given by A plus N minus 1 times D. right? So can you guys find the 97th term? What is the 97th term here, guys? Quickly.
So it's 292.
292. Yeah, right. So it's 4 plus 96 hops of size 3. So it's 288 plus 4, which is 292. Was the previous problem 292? Someone had, oh, Ahan had already predicted this question, looks like. Look at the 292 here. Such visionary we have in class. Okay, good one. 292, right? Cool. Okay, so what is the other thing that we want to know in an arithmetic progression? The sum of n terms. So suppose I want to know the sum of the first 73 terms. That's also another possibility in a question, right? How do we do this? Okay, so let's do this. I'll make more space. Not able to add. Just one sec. Let me just stop share and then add more pages and then resume the share. Okay, so far so good, right? Any questions meanwhile?
No, sir.
All clear, right? Okay. Okay, so now what am I interested in? I need the sum of the first n terms. So in fact, let me just derive it quickly. So Sn stands for the sum of the n terms. The first term is A. The second term is A plus D. The third term is A plus 2D, right? The last term is A plus n minus 1 times D. The term before this is A plus n minus 2 times D, right? And what are we doing with all this? We are adding them. That's what Sn is, right? It's literally adding all of these terms. You agree with this? Sn? Now, I can also write Sn in the reverse order. Now, why will I do it? I'm just being creative I don't expect you to come up with this, but people who derived a formula for Sn have come up with this cute method, right? So they'll write the last term first, A plus n minus 1 times D here. And then they'll write the penultimate term here, A plus n minus 2 times D here, and so on. And then they'll end with the second term here and the very first term here. Just reversing the order. That's all I've done here. Now, why would one do that? Now, if you add these two, right? So 2 times Sn. Sudarshan, I'm just going to mute yours. Okay. So 2 times Sn is, if I'm adding term by term, right? If I'm adding this block, and then I'm adding this block, and so on. So let's see what happens in each block. So when in the first column that I'm adding, it's 2A plus n minus 1 times D. Agreed? That's the first block. Now the second block, when you add, again, we have A at the top and A at the bottom. So that's 2A. And then how many D's do we have? We have 1 D and then n minus 2 times D. So it's 1 plus n minus 2, which is n minus 1. But it's no surprise, right? It's getting compensated. There's more D's towards the end. There are fewer D's towards the left. And then when you're reversing and adding, they're sort of compensating for each other. And the penultimate term here is A plus, again, same logic, n minus 1 times D. The last one is also 2A plus n minus 1 times D. So what do we have? We have pairs of numbers, each adding up to 2A plus n minus 1 times D. Agreed, Sumer? Okay, so this sum on the right-hand side is how many pairs do we have? As many terms that we have. We have n terms, therefore it's n pairs, each pair adding up to 2A plus n minus 1 times D. Right? And that is your 2Sn. Therefore, Sn is just this. Right? So that's the formula for the nth term. Not the nth term, the sum of the n terms in an arithmetic progression, right? But this is little clumsy. I mean, yeah, you should remember this formula for sure, but you should understand what's happening here. If I write out this formula in a different way, it's easier to remember. It's just n times the average of the very first and the very last term, right? In fact, we just said it's sum of any pair is this. the very first and very last is a plus n minus 1 times d, right? The average of those two. So it's just a simple average of the first and the last term, and then multiply that by n. Because we are saying if I add any two numbers which are equi-spaced from this end and that end, they'll add up to the same sum anyway, because they are all uniformly separate. Which is why I might as well take the very first and very last and add them and say every other pair will add up to the same. So I might as well consider n such pairs are there. Does it make sense, guys? Okay, so this is this. Now let's verify this. So this is the sum of n terms. Ahan, you're with me? Sudarshan, I have to mute you, or if you're not, if not, I have to disconnect you, Sudarshan. Okay, so it's n times this, correct? Now let's verify this for just a simple thing, right? So we know the sum, the natural numbers itself is an arithmetic progression, right? 1, 2, 3, 4, so on till n is an arithmetic progression. Do you agree? And we know that the sum of n terms is n into n plus 1 by 2. Let's arrive at this using this formula and see. So this is an arithmetic progression where the starting term is 1. And this is an arithmetic progression where the common difference is also 1, which is why it's 1, 2, 3, and so on. And let's say I want to find the sum till n terms. So I'll apply this formula blindly and see what I get. So it's n times average of the very first and the very last term. First of all, what is the last term? Last term is n. But do I get the same n? If I actually use the a plus n minus 1 times d, do I get n? 1 plus n minus 1 times 1. So indeed it's 1 plus n minus 1, which is n. So no surprise that the nth term is n, as the formula also says. So are you with me? Okay, so it's the average of the very first and the very last term is this. So this is how we get that n into n plus 1 by 2. The sum of terms in an arithmetic progression, in a sum of the natural numbers, right? Okay, so back to this question, right? So can you guys find, for this question, can you find S10? Can you find the sum of the first 10 terms? First do it literally, they're all small numbers, right? You can just add it all up, and then you can also try it with the formula and just see whether both match. Or should I give a small number? Let's do so that it's not too painful, right? Let's do S6. So only one more term. After 16, there's one more term, 19, right? Can literally add it up and then use the formula to check. I'll write out the formula here just in case. But as you write it, remember, it's just n times average of the very first and very last. I'll just write f plus l. First term plus last term divided by 2. And this is the last term. Un is what I'm calling the last. L for last, f for first. When you're adding,
something 69.
69. And when we are adding also, we are getting 69. See, so how would we add using the method I showed you? 4 plus 19 is also 23. 7 plus 16 is also 23. 10 plus 13 is also 23. So we have 3 pairs of 23, which is 69. So whatever we did generally, we can actually see it happen here, right? So it's 23 times 3, which is 69, right? Or in other words, if you use the formula, there are 6 numbers. The first term was 4, the last term was 19, the average of the 2 was this. And the 6 by 2 is the 3 that we just saw. There are 3 pairs, 6 by 2. So indeed, it's 69 as well. Does it make sense? Okay, cool. So there's 2 things to understand is just those 2, right? So obviously the limitation of arithmetic progression is we can do it only if the difference is a common difference, right? That's what the definition of arithmetic progression is. For example, I cannot derive the formula for 1 square plus 2 square so on till 10 square using arithmetic progression because it's not an arithmetic progression in the first place. The difference is not uniform, right? So I'll have to resort to something else for finding that sum. Okay, that's a different story altogether. Okay, now let's do some few basic problems, right? So do you guys have a specific book that you'll be following in school? Have you been given any guidance? Is it Hayes and Harris or?
Not yet. So we've not been told. We've not really started classes yet.
Okay, all right. Okay, all right. Let me just, are you able to see my, this thing, the PDF, or no, I'm just still sharing the other one, right? Okay, fine. I'll just copy paste a problem. Okay, so let's, can we try this? We can discuss as we go along, in fact. Okay, so let's do each part and then discuss. Prove that the sequence is arithmetic. Ahan, you want to take this? How do you prove something is arithmetic?
So the common difference, right?
Exactly. You have to show that the difference is common, and he has given in the hint itself. So find a difference between two successive terms and show that it's a constant. So can you do un plus 1 minus un and see what you get?
So what does U mean here again?
U is a general term. N is the suffix of the term. So the nth term.
Okay.
Ahan, what do you get for un plus 1 minus un?
So just 1 second.
Yeah.
I'm not sure, so but I'm getting 1s.
You're getting 1. Okay, Sumer, what do you get?
So then I'm getting 3.
3.
I'm not done with it yet. Just a second.
Yeah, it is 3. It's not very difficult, guys. So un plus 1 is what? Un is just a template, right? So if it's un plus 1, n ke jagah mein I have to put n plus 1. That's it. So un plus 1 is just this. Un is just this as it's given. If I'm subtracting the 2, the minus 2 get cancelled. The 3n get cancelled, leaving just 3. So the difference between the nth term and the n plus 1th term is a constant, which is 3. Does it make sense, Ahan?
No, so I didn't understand.
Okay. As you rightly said, what makes an arithmetic progression? Successive difference must be a constant, right?
Yeah.
The difference must be uniform. So do you agree that the nth term and the n plus 1th term are two general successive terms?
Yes.
U7 and U8, U99 and U100. It's a general pair of successive terms.
Yes.
And the template for UN is already given in the question, 3n minus 2. So what will un plus 1 be? Instead of n, you just have to replace it with n plus 1.
Okay, so understood.
Right? And literally the difference between the two.
Yes.
Right? Okay, so first one is done. Okay, find U1 and D. Sumer, what is U1?
So it's just 1.
U1 is just putting n equal to 1, therefore it's 3 into 1 minus 2, which is 1. Okay, and D, Avya?
Isn't it just 3?
3, what we just found. We said the difference is common, and that difference is 3. Okay, in fact, we can write this as to represent the same arithmetic nth term. So it's minus 2 plus, ideally I want n minus 1 hops, right? Right? Times 3, correct? But we have minus 2 plus 3n, but here it's minus 2 plus 3n minus 3. I don't want the minus 3. I'll compensate for it by adding plus 3. Are you guys with me? Ahan, did you understand what I did?
Yes.
Okay, so therefore effectively it's minus 2 plus 3, which is 1, plus 3 times n minus 1. And you can see that this is your A and this is your D. So it matches with the A and D that we got, right? He has written it as 3n minus 2. I can write it as 1 plus 3 times n minus 1 because I need that n minus 1 to have that in the same form. Okay, find the 57th term. Just formula substitution, right? Let's quickly do it together. It's 1 plus 56 times 3. Agreed. So whatever that is, 169. Okay, can we do the last part? What is the largest term that's smaller than 450? And which term is it? For example, which term meaning? It's the 17th term is what you have to answer.
I think it's a 149 term.
149. Okay, all right. So again, it's fairly simple, right? So let's say it's the nth term. So n minus 1 times 3. That's the nth term.
So it's 150 at 150.
Okay, you have to be very careful on the edge case, right? So which means n minus 1 times 3 should be less than 449, right? So n minus 1 should be less than 449 by 3, right? So n should be less than 449 by 3 plus 1, right? So which is, so this is 150 and change, right? So n should be less than 150.66 maybe. Therefore, n equal to 150. So the 150th term will be the term which is smaller than 450, but the 151st term will exceed it. We can quickly check, right? 151st term will be this guy, which is 451. And the term before that will be 448, which is not exceeded. Okay, fairly straightforward. Can I add one more this thing to it? I'll just say, which is the first term where the sum of all the terms until that exceeds 100. Okay, I'm not writing it down. It's too much to write. You understood, right?
So
So
can you
what-
please repeat that?
Okay. Okay, I'll just say, okay, I'll just find the smallest. Okay. Find the smallest n where Sn exceeds 100. I'll write it out, okay. So Sn is greater than 100. Find the smallest n. So obviously the sum of the first 25 terms will easily exceed 100. But what is the smallest n when it first breaches 100?
Is it 35?
35. Okay, all right. I haven't worked it out. Let Ahan and Sumer also take a minute.
So is it like reaches 100 or crosses 100?
I have given the problem is greater than 100.
Okay, so then it's 35.
35. Okay, so 35 is Ahan's answer. Okay, Sumer, Avya, what do you have? You need a bit of quadratics for this. So Ahan, you did using quadratic or what did you do? But basic quadratic, nothing very complicated.
So I'm getting the wrong answer
You're getting the wrong answer. How do you know it's wrong without knowing what's the correct answer?
because it's too high of a number.
What is it? Just call it out. What do you get?
57,
57?
67.
67. Yeah. Okay. So clearly it's on the higher side, right? So let's see what's happening. So what are the numbers? So it's 1. First term is 1. Second term is 4. Third term is 7 and so on, right? Because the sequence is 3n minus 2. 3n. So the nth term is given as 3n minus 2. Right? This is the nth term. This is the un. This is the u1 or a. So this is the a or u1. Right? So what is Sn? We know Sn is n times the average of the very first and the very last term. The very first term is 1. The very last term is 3n minus 2. The average of these two is this guy. Correct? So the expression that we have,
Oh, so I did the wrong. I forgot the formula. I forgot to multiply by n.
okay, cool. So yeah, all of these mistakes happen at the beginning, right? So n times 3n minus 1 by 2. Now I have stated that this must exceed 100. Ahan, is this what you got? You would have got a quadratic like this. So which is 3n square minus n is greater than 200. So which means 3n square minus n minus 200 is greater than 0.
So, but wasn't the formula 2a? Like, so shouldn't it be 2 plus? Actually, no, that'll just be 2 plus 3 and minus 3, right? And it'll be the same thing.
Exactly. Yes. So it's a plus n minus 1 times d. Or you can collectively look at it as 2a plus n minus 1 times d. I like the former because it's clearly saying the first term is a, the last term is a plus n minus 1 2 times d, and then I'm adding the 2. Right? So, Ahan, did you end up getting a quadratic like this?
No, so
Or
I did like completely different, please.
Okay, I'll hear you out in just a second. Okay, but you guys have done quadratic, right? But if
Yeah.
not also, it's not a problem, right? So even without quadratic, one can do this, right? So it's n times. So I'll write it as, I'll erase this so that it is not distracting. Nothing to do with all of this. So right here, I can say n times 3n minus 1 should exceed 200, correct? Right? So to very first approximation, I can say 3n minus 1 is approximately 3n, right? So I want a number where 3n square is approximately equal to 200, which means n square is approximately equal to 200 by 3, which is 66 ke aspas. So approximately n equal to 8 is where I have to, or thereabouts is what I have to try. And then just by trial and error, I can quickly narrow down. So if n equal to 8, I get 8 into, how much is this? 24 minus 1 is 23, right? And this is clearly 184 or something, not exceeded. I'll go for 9. 9 into 27 minus 1 is 26, right? So 260 minus 26, right? Essentially. So it's definitely exceeded 200. So I'll just say n equal to 9. You understood how I very approximated, very
Yes. Sir.
hand wavily did it, just without any calculator, without any quadratics, we can do this, right? But if you actually have to use quadratic, no, the formula will do quadratics in detail, don't worry. But for now, just take it as an equality and solve. So it's 3n square minus n minus 200 equal to 0. How do you solve the quadratic? Using the factorization or using the formula? Let's go for the formula. So it's minus b plus or minus. We did quadratics, right? As last class, basically we just covered b square minus 4ac minus 4 into 3 into minus 200 whole upon 2a. So it's 1 plus or minus 200 times, this becomes minus, minus becomes plus. So 600, 2400, 2400 plus 1, 2401. It's 2401 perfect square. Yeah, I think it's 49 square, right? Can you guys do? What is, do you have a calculator? Can you pull up and see what square root of 2401 is?
Yeah, so it's 49.
49 square, right? Okay. So the negative root is obviously to be ignored. So the positive root is for 1 plus 49, which is 50 by 6, which is 8 and change, right? 8.66. So which means the answer is between 8 and 9. This still doesn't tell the full story. So does it mean answer is 8 or does it mean answer is 9? Right? You're not sure. Right? Actually, then we can, using quadratics, we'll do it using quadratics. So what's happening here? You have the vertical axis, you have the x and y, and this is a quadratic which has 2 roots, right? This 3n square minus n minus 200 is a function, correct? It's a function, that's your y, right? And the 2 roots are, one which is a negative root, which is useless to me, so I'll ignore it completely. The positive root is telling me 8.66, which means if n is allowed to be a non-integer, when n equal to 8.66 is when this expression will exactly reach 0, but I want it to exceed 0, therefore I'll have to go with 9. So 8 is here, 8 does not suffice, 9 is where it exceeds 0. That's how you graphically interpret it. Does it make sense?
Yes.
All good? Ahan, you're good? Ahan, what is the mistake you made to get 35?
So I don't think I understood the question properly because I still don't understand how it's 9. So like, is it like which term exceeds 100 as a value? Just like, because if it's 9, then
No. What does Sn mean? Sn means the sum of the
Yeah.
first n terms. So the question is, which is the smallest n when the sum of all the terms until that exceeds 100?
yeah, so like that's what I made a mistake and I interpreted it wrong. I thought it was like the single value. That's all.
If it's a single value, then I would have given it as un. No, I would not have given us.
Yeah, so that's why I read it wrong. So I like,
Yeah, I was a little surprised also because you called out the answer also very quickly. So you couldn't
yeah.
have done so much in such quick thing, right? So,
Yeah.
but does it make sense though now?
Yes. Sir.
Okay, cool. So that's arithmetic progression. Let's move on to geometric progression. Okay, so obviously I'll be assigning some homework problems. So geometric progression is GP. Okay, very similar idea. You have a starting point, and then it's multiplicative hop. Instead of additive hop, it's multiplicative hops. So 2 times 3, 6 times 3, 18 times 3, right? So to specify a geometric progression, you need two things. One, what is the starting term? Second, what is the common ratio? It's not common difference, it's the common multiplier or common ratio. The ratio of the second term to the first term, or the 7th term to the 6th term. All of these ratios must be constant. Only then it makes a geometric progression, right? So that ratio is, and remember, ratio is the latter by the former. So it's the 7th divided by the 6th, not the reverse. So it's 6 divided by 2, 54 divided by 18, and so on. So in this problem, it's 3, right? And suppose I'll have to arrive at the 10th term. What will I do without knowing any formula? I will say, is this multiplication problem? I'm starting with 2 and I'm multiplying 3 several times, times 3, times 10, times 3, times 3. How many times I'm doing? However number of hops that are required. So to reach the 10th term, I need 9 hops. So it's 2 times 3 power 9, right? And in a generalized form, that's what it is. The nth term is the starting term A times the common ratio R raised to n minus 1. Because to reach the nth term, I need n minus 1 hops. Is this clear? Sumer,
Yes.
all good? You had a question?
No, sir, I was just
Okay.
getting.
Cool, right? So this is un. And sometimes people call it an, right? Whatever, an. Sometimes people call it tn. All of these are letters people use to denote the nth term. T, A, U, and all that. But if it's S, it's sum of n terms, right? We'll come to that next. So the next obvious question is, how do I find the sum of the first 10 terms of this geometric progression? So Sn is for sum. T, A, and U are all used to specify the term itself. Okay, so again, let's get an expression for Sn. Let's derive it. Okay, so what is Sn? Sn is, in a general way, it's A plus AR plus AR square all the way till the last term is AR power n minus 1. Agreed? Okay. Now, how do I solve this? Just like there was a creative way of solving the sum of terms in arithmetic progression, there's a creative way here also. So people who discovered this took this and multiplied this with R. R times Sn. So the very first term is AR, the next term is AR square, and so on, correct? And they shifted it and started writing it here. The very first term is AR, they wrote it below this, and you can see where we are headed. We'll be subtracting. The second term is AR square, which is written below this. And the penultimate term will be AR power n minus 1, AR power n minus 2 times another R. And the last term will be AR power n. Agreed. So you're multiplying and shifting it and writing this way. And now when I subtract, okay, doesn't matter. Okay, I'll subtract the first minus the second. It doesn't matter. So it's 1 minus R times Sn equals. Now this guy after subtraction will give me A. Every other subtraction will be 0, except the last one, which will be AR over n with a negative sign. So every pair will get cancelled, except the very first and the very last, because they don't have a pair to go with, right? So this is A.
So why will it be negative?
Because I'm subtracting the first equation minus the second equation, right?
Oh, okay.
Right, Sumer? Okay, so it's a minus a r power n is this Sn times 1 minus r. So I'll bring the 1 minus r here. I can write it as this. So in other words, a times 1 minus r power n upon 1 minus r. I can also write it as a times r power n minus 1 by r minus 1. If I subtracted the second equation minus the first equation, everything would have got negated. So both formulas are the same. Both are in prevalence. Typically, when r is a number greater than 1, you tend to use this one, so that you have a positive number by positive. We all like to do it with positive numbers, right? So when r is greater than 1, I'll use this. When r is less than 1, for example, this is an arithmetic progression 2. 8, 4, 2, 1 is an arithmetic, not arithmetic, geometric progression 2, right? Where the common ratio is half. In that case, I'll use the formula where it's 1 minus r power n, so that I have positive over positive, right? But whatever you use, you won't go wrong. Worst case, you'll get a negative number by a negative number. Therefore, the answer will be positive. Right? Does it make sense, guys? Okay. I mean, that said, it's not like geometric progression. The answer cannot be negative at all. Obviously, there can be problem. In fact, I'll make up 1 or 2 where you get out of that myth, right? Okay. So 8, 4, 2. Let's practice one simple thing, right? You guys already know this, right? When I add the powers of 2, right? When I add the powers of 2, it's always the next power minus 1. Do you know that? 1 plus 2 plus 4, so 1 till 16 will be 1 less than 32, will be 31. You know this, Sumer?
No, sir, I didn't know that.
But you can make that observation now, right? So 1 plus 2 plus 4 is 1 less than 8. 1 plus 2 plus 4, right? So 1 till 128 will be 1 less than 256, right? Let's apply this in this problem. So this is a geometric progression. The starting term is 1, right? The common ratio is 2, right? And the nth term is a into r power n minus 1. So it's 1 into 2 power n minus 1. So that's the nth term, right? And suppose I have to, and sure enough, I can check. The fifth term is, can we just quickly check? 2 power 5 minus 1. Indeed, it's 16. 2 power 4 is 16. Now, suppose I want to do S7, right? I want to do the sum of the first 7 terms. The formula is telling me I'll use this one because r is greater than 2, right? So I'll use a into r power n minus 1 by r minus 1, which is 2 power 7 minus 1. So which is why I was saying it's the next power. My next power meaning what? U7 would have been, U7 would have been 2 power 6, right? U7 would have been 2 power 6. So it's 1 plus 2 square plus 2 cube all the way till 2 power 6 is 2 power 7 minus 1, which is the observation that we made as well. Makes sense? Okay.
Yes.
Yeah, and like I was saying, it can be applied for r as a fraction also. So can you guys work out what is the sum of, okay, in fact, I'll make up a problem. So I have this geometric progression 27, 9, 3, 1, and so on. Okay, so 2 questions. Find the 7th term. Okay, and then second question, find the sum of the first, I don't know, 8 terms. Can we do both of them? So this find the 7th term means find U7. This is U7. So find U7, find S8. You can give your answer in terms of powers of 3. If it's too much of fraction, you can just say answer in terms of fractions with powers of 3. That's fine. Anyone with U7?
Yes, sir.
Yeah, what is it, Arya? Abhya?
Again, so I can give in terms of powers of 3, right?
Yeah, sure. Please
So
do.
27 upon 3 raised to the power 6.
Okay, so 27, A times R is 1/3 power n minus 1. So,
Six.
all right. Yeah. So, of course, we can simplify it a little. So, this is 3 cube. This is 1/3 power 6. So, answer is 1/3 cube,
Minus, yeah.
right? Which you can write it as 1/27. So, it's not a big number, right? 1/27. And which we can see without even a formula, right? Which is why I gave a small number so that you can test it out. So, I can literally complete this as 1/27.
Minus 3, right?
Sorry?
Is it not just 3 raised to minus 3?
That's the same thing.
Yeah,
Yeah.
3 raised to minus 3 is 1/3 power 3. Yeah, same thing. Sumer?
Yeah.
Yeah,
Okay.
3 raised to minus 3 or 1/3 power 3, 1/27, all of same. And we can literally handwrite it and she check whether we got 1/27. Small number, right? Find S8. Someone? Yeah, Sumer, you have something?
No, sir. I don't know why this is.
Shall we do it together or you guys need 1 or 2 minutes more? Avya, how's it going?
So just 1 second.
So I'm getting 40.5.
40.5.
So rounded, it's 40.49, but I'm just saying 40.5.
Okay, can you give it in terms of fractions? Or
So then just 1 second. I'm just,
Ahan, you have something?
So I'm like not getting it like from like I'm getting the same answer somewhere if I do it like without the formula.
Without the formula, meaning literally you
Like-
added 27 plus 9 all the way till
So
1/81.
Yes, like I understand that's the answer, but when I'm putting it in the formula, it's not like coming out like it's
Okay, let's discuss, right? The 8th term is 1/81, right? So to quick approximation, I can quickly see 27 plus 9, 36 plus 3, 39 plus 1, 40. And these are all very, very small numbers. 1/3 is fine, a sizable fraction. After 1/9, 1/27, they're all very tiny. So it is true that the answer should be slightly more than 40, right? That way it's clear. In fact, I'm going to talk about it after this problem on one other concept. Okay, so now let's apply the formula and see whether we indeed get that, right? So Sn, S8 is, what is it? The starting term is 27, A times R power n. Here there's no n minus 1, it's R power n minus 1 or rather 1 minus r power n I'll use, because r is less than 1, right? I'll like to use this. 1 by 3 power 8 upon 1 minus r. This is what you guys got?
Yes.
Yeah, so now it should be easy, right? So it's 27 times. So I can write this as 3 power 8 minus 1 upon 3 power 8. In the denominator, I have, this is 2/3, which will do Pulti and come up as 3 by 2, right?
Yes.
So effectively, one of the threes can, so in fact, what is this? This is 3 power 3, right? And this is another 3 here. And can knock off with 3 power 8. Okay, so effectively I have 3 power 4 by 3 power 8, which is 3 power 4. So I have 3 power 8 minus 1 upon 3 power 4 times 2. Whatever that answer is, right? To very approximately, I can ignore the 1, given that 3 power 8 is a significantly big number. So effectively, it's 3 power 4 divided by 2, which is why it's 40.5 approximately, as you're right. But the accurate answer is this. Does it make sense? Yeah.
Yes, sir.
Right.
Yes.
Now, let's see what happens. Suppose I didn't want the sum of the first 8 terms. I want the sum of the first 100 terms. Right. Exactly same logic. So let's go through the paces. It'll be 1 by 3 power 100 by 1 minus 1 by 3. So same thing will happen. So this is instead of, right, nothing is changing, right? So literally it's 3 power 3 into 3 power 100 minus 1 by 3 upon 2 by 3, right? So it will turn out to be same thing, 3 power 100 minus 1 by, no, did I make a mistake? 3 power 100. This is 3 power 100 here, right? Right. So what do we have? We have, we will get 3 power 3 into 3, and then there'll be the divide by 2 is sitting here. Here I'll have 3 power 100 minus 1 upon 3 power 100. This is what I'll get, right? So this is essentially 3 power 100 minus 1 by 3 power 96 times 2. Correct? It's just simple simplification, right? And this approximation is even more true. That's 3 power 4 by 2. At least 3 power 8 versus 1. 3 power 8 is how much? 3 power 4 is 81. 81 square is approximately 6,400. So 1 is still in the range of 6,400, right? It's only 1 by 1,000 or 1 by 10,000 of it. Whereas 3 power 100 is going to be a huge number. Compared to that, 1 is very trivial. So it's all the more going to be a fair approximation to call it 3 power 4 divided by 2, which is 40.5. Correct? Are you guys agreeing with me?
Yes, sir.
So in fact, one can potentially talk about S infinity. In a geometric progression where the common ratio is less than 1, we can talk about S infinity, which is the sum of infinite terms of the geometric progression. So what is we have A times 1 minus R power n by 1 minus R. So in this problem, A was 27, R was 1/3, right? So in fact, I won't write, I'll write a zillion or something, right? Upon 1 minus 1/3. Now let's understand what's happening, right? 1 minus 1/3, the bottom we understand 27, we understand 1. What is 1 by 3 power zillion? Almost 0. Because when you take a fraction and keep multiplying, effectively it dies down to 0. So very approximately, it is as if the R power n term did not even exist. Right? So in other words, S infinity is A by 1 minus R. So sum of infinite terms is just A by 1 minus R.
So, but
And
won't this just happen if like R is a fraction?
yes, we can apply this concept only if R is a fraction. If R is a number like 3, we cannot even talk, because if you take 2, 6, 18, 20, 54, then the term itself is going to infinity. The sum of the terms will obviously going to infinity, right? Right? Whereas if the term is dying down, then one can talk about potentially the term itself is dying down to 0, but the sum is approaching a constant. So what is that constant? That's the question, right? So in this case, it's a by 1 minus r. So for our numerical problem, it's 27 by 1 minus 1/3, which is the same 27 times 3 by 2 that we approximately found out, right? All along, that's what was happening. So this is also approximately 81 by 2. This is a better approximation of 81 by 2. And then when you take infinite terms, it literally lands at 81 by 2, a by 1 minus r. Does it make sense? Okay, which is why you would have also seen some puzzles. I don't know, we have done puzzles, right? There's an ant. First day it covers 1 meter. Second day it covers half a meter. Third day it covers 1/4 meter. Have you heard of this problem? Okay, so there's an ant. Okay, so the first day it covers 1 meter. Second day it covers half meter. Third day it covers 1/4 meter, and so on, 1/8 meter, and so on. So the end of an year, how much distance do you think it's traveled? Just take a guess without thinking too much.
So 2 meters.
2 meters, exactly. That's a geometric progression, right? So 1, half, 1/4, 1/8, and so on. And we want S365, right? So which is what? Almost S100 only, because it's a into 1 minus r power n by 1 minus r, right? So half power 365 is almost 0. So it's as if almost S infinity only, right? So it's a by 1 minus r, which is just 2. So the sum approaches 2.
Yes.
Okay. R can be, okay, we agreed that R can be greater than 1, R can be less than 1. R can be negative also. For example, okay, let me give you a problem. Okay. So let's say, who should I pick? I'll pick Ahan. Okay. So Ahan and I are playing a game. Okay. So initially, I have, let's say, what's 100 rupees. Okay. 100 rupees. And this guy has 0. Okay. We play a game where in the first step, I give him 50, right? So I give him 50. So, okay, I'll write it like this. I give him 50. The next day, he gives me back 25 bucks. The third day, I give him 12.5, and then he gives me whatever, 6.25 the fourth day, whatever, right? It keeps going on. Let's say we do this operation for 10 years. Then very soon, you can see that the exchange is going to go down to almost very minuscule quantity. I'll give him maybe a trillionth of a paisa, and then he'll give me even half of that the next day, and so on. So what is the steady state? At the end of this, how much wealth will Ahan have? How much wealth will I have? Can you guys work it out? It's geometric progression, literally. Any idea, or should we do this together? We'll do it together. Okay. All right. So think of how much wealth I have, right? Do I need to create more pages, or I have pages? Okay. Okay. How much wealth I have? On day one, I have 100, right? I'm starting with that. I'm just going to count my profit and loss. On day two, I'm down by minus 50. I made a loss of 50 by giving a hand. On day three, I had a gain of 25, right? Let's say on day zero, God gave me $100. That's 100. Day one, I lost. Day two, whatever. Day one, you understand, right? And the next day, it's minus 12.5 and so on. And this is a geometric progression where the starting term is 100. The common ratio is minus half. And I'm saying I'm doing this for 10 years, which is a long time. So effectively, it's S infinity is what I want. So S infinity is A by 1 minus R. So it's 100 by 1 minus half, which is 100 by 3 by 2, which is 200 by 3, which is approximately 66.66, right? I'll have this much. And obviously, money has not gone out of the system, right? Only 2 people are playing this game. So, sorry, I had 0. Sorry, I had 100. Ahan came with nothing. And all that's happened is money has exchanged hands. At the end of it, if I have 66, the balance is what Ahan would have. Ahan would have the balance 33.33. Does it make sense? Because no money has entered the system. It's just the 2 of us playing this game. Does it make sense?
Yes.
Okay.
Yes.
Yeah. Okay. Another problem is, okay. So for example, you have a square. Okay. Can use the grid lines itself. I could have drawn up. Okay. So this is a square. Okay. Let's say it's 4 units by 4 units. I can join all the midpoints. And that's another square. I can do that one more time. I can keep doing this till eternity. So can you find the sum of the areas of all of these squares? Can you do it? Not just the 3 squares, but infinitely long. The initial square, big square, is 4 by 4.
So this was find the sum of like the area of the 3 squares, right?
Sorry,
So what do we supposed to find the sum of the area of the 3 squares?
not the 3 squares, infinite squares. You keep doing this process over and over again. So what will the sum of all those infinite squares be? It will keep decreasing, but the sum will approach a constant.
So I think it's just 32.
Okay, just 1 second, guys. I'll do.
Yeah, sir.
Okay, 32. Okay, let's check. Okay, so the initial area is 16. Okay, and the second square has a side of how much? This is 2, this is 2, right? The side becomes 2 root 2. You agree? This is 2 root 2. Yeah, so the second square, the area would be 2 root 2 into 2 root 2, which is 8, right? And then you can clearly see that the third one is 4, 2 by 2, and so on, right? So yes, 32. A by 1 minus R. We have seen this many times already today. Therefore, S infinity will be 32. Okay. And then we can also use, okay, I want to do banking, how you can have compound interest. So compound interest is another geometric progression, right? So the amount of money you have in the bank, right? So let's say you start with the principal of P, right? At the end of the nth year, you have this, correct? This is the formula for the amount in the bank based on compound interest. So that's a geometric progression. Of course, you're not adding all of it, right? It's not like you keep accumulating. At any given time, this is like your UN, nth term, right? Or rather, I should say, okay, at the end of the first year, so you have to be careful about the labeling here, right? So U1, let's say U1 is the value at the beginning. So it's P into 1 plus R power 0 because nothing has happened. This is the starting value, the U1. U2 is the value at the beginning of the second year. Again, the question could be different. You have to be very, very careful. The problem giver might say U2 is the balance at the end of the second year. I am defining it to be at the beginning of the second year. The beginning of the second year is effectively an interest for 1 year. So this, by this logic, UN will be at the beginning of the nth year, will be P into 1 plus R power n minus 1. Right? At the end of at the beginning of the next year, it will become P into 1 plus R power n, which is effectively the end of the nth year, which is what I started writing here. This is at the end of the nth year. Yeah, you guys are clear with the distinction, right? So depending on the problem, be careful, guys. Okay. So now we are almost up on time, but one thing what I want to do is, you know how mortgages work, right? So let's say you take a home loan for $1 million, right? And then how do banks work? So banks will say, okay, today I'll give you $1 million. Okay, so I've given you $1 million because I trust you. You seem like a nice guy, right? At the end of every month, and we'll simplify it to be every year. Technically, it's typically monthly, but let's say at the end of every year, you give me some small amount, right? And you do this, you better pay me at the end of 30 years, the full balance, right? And let's say I'm going to charge you 6% interest. Okay, now the question is, can we use geometric progression to figure out what this amount should be? So maybe you might end up figuring it out that the amount I owe every year, let's say this is, I'll say 40 years. Okay, if I blindly do 1 million upon 40, 1 million upon 40 years, how much will that be? 100,000 upon 4, right? 25,000, right? But obviously, if I'm paying only 25,000, then bank is getting fooled, right? It's charging 0 interest. It won't do that. Correct? It's expecting me to pay yearly some amount more than 25,000. Maybe that amount is the equal installment. It's equal monthly installment, EMI. In our fake problem, it's equal yearly installment. Maybe that value would work out to be 28,868.72. I'm just making up some number here. How do we arrive at this fair number? If the bank is going to say every month I have to pay 40,000, then I'll say, I don't want your loan, boss. I'll manage somehow myself, right? Right. So what is a fair number? If the interest rate is 6%, what should the equal installment be? And you can use geometric progression to arrive at this number. So we'll do that at the beginning of the next class. But is this clear, guys, so far? Arithmetic and geometric progression.
Yes, sir.
Okay, I'll give a few problems for homework, for practice. So work on them. Okay, chalo, we'll end the class here today. Okay, bye.
Thank you, sir.
Bye.
Thank you, sir.
Sure.